In this video, I'll be going over an example of a dihybrid cross. I'm not going to be doing a Punnett square because when you're dealing with more than two genes or two or more, even with one gene, it's a big waste of time. It's better just to do it with pure statistics. So in my example, I'm saying that I have some creature that has these two traits. F is for fur color, where capital F is the dominant allele, that is black fur. Lowercase f is brown fur, the recessive. Capital E is for eye color. So capital E is for black eyes, lowercase e is for red eyes. So black fur, brown fur, black eyes, red eyes. Now let's say I cross two individuals that are heterozygous for both of these traits. And what if the question was, what is the probability of having, what's the probability of having a child that has black fur and red eyes? We could do a Punnett square, or we could just see, oh, well, these are two independent events. So black fur is, we know, if we have a dominant allele. So how can we get a dominant allele for this first one? Well, this parent can give its dominant allele, and this one can give its recessive. This one can give its dominant, and this one can give its recessive. That's for the case where our offspring, I'll note it in purple. If our offspring is heterozygous, we can either have dominant and recessive, or we could have dominant and recessive. So for the case where our offspring is heterozygous, there's two options, 1, 2. And for homozygous dominant, there's one option. They've got dominant from both parents. There's one other option, which is if you got recessive from both options. That's not the one we want. So there's 3 good outcomes divided by 4 possible outcomes. So there's a 3/4 probability that it'll have black fur. Now what about red eyes? So we know that each parent can either give dominant or recessive allele for eyes, and we know that the one that we want is homozygous recessive. Therefore, we need this parent to give off its recessive and this parent to give off its recessive. There's one option. There's 1 out of 4 possible outcomes, 1 possible wanted outcome over 4 total possible outcomes for red eyes. These are 2 independent events, so the probability of both of them happening, we learned in the first video, is just the product of the 2 events. Which is 3/16. That's one approach to solving this problem. Notice that in this approach, I still derived all 4 possible outcomes, which is essentially just doing 2 Punnett squares. Not very efficient. So another approach would just be to see, well, for it to have black fur, the probability of it being homozygous dominant, oops, let me make this smaller. Probability of our offspring being homozygous dominant, there's a 50% chance here and a 50% chance here that it gets dominant and dominant. So there's a 1/4 chance, right? 50%, 1/2 times 1/2 is 1/4. I'll write it out. 1/2 times 1/2 equals 1/4 for homozygous dominant. For heterozygous, there's a, well, this one can give off either one as long as this one gives off specifically the other. So, two possible things. The first parent can give off either dominant or recessive, and the second parent has to give off the other one. That's 2 out of the 4 possible because there's 2 different alleles each. So that's 1/2. So then probability of black fur would be 1/4 plus 1/2, which is 3/4. Just as we found up here. Same thing, just a different approach to doing it. Here I did essentially a Punnett square. Here I did it more mathematically. And then for the red eyes, I know that this parent must give this recessive allele, which there's a 50% chance, and this parent must also give that recessive allele, which there's a 50% chance. And that is this 1/4. So this is the exact same answer, just solved via a more mathematical approach. So yeah, hopefully as you guys progress through this class, you'll try to think of different ways to approach the same problem. Some ways might be easier or harder given the specific problem